Namaste. This is the course on Sanatana Dharma for youth. This is the second day on the Vedic mathematics. Today we will be going into multiplications and divisions. Dr. Goutham Mukherjee will continue the class today. We will start with Prarthana. Shuklam Paradaram Vishnum Shashivarnam Chaturbhujam Prasannavadanam Dhyayet Sarva Vignopashantaye Saraswati Namastubhyam Varade Kamarupini Vidyarambham Karishyami Siddhir Bhavatu Me Sada Harihi Om Shri Gurubhyo Namaha Harihi Om. Dhanyavadaha. We will start the class. Over to you, Doctor.
Namaskar. Thank you, Shravandiji. Up to yesterday, we did different multiplication method. We did comparison after learning all the division, methods of this base and sub-base near a tens power, and then going to this Chirjagabham method or Nikhilya method earlier and Tejagabham. Finally, we did a comparison between all different multiplication method. We all discussed like that, and it was even conventional method also discussed, comparison, it was compared, and with vinculum and non-vinculum. So these are compared, and then some algebraic background of the conventional method and Urdu Tejagabham, these are discussed. Multiplication was discussed already. Now today we go straight away to division, and that is called division by Nikhilya method. The purpose of this division is not going, will not go towards the fractional level, like after decimal point, some to 1.53 and like that. It will go simply, we'll end up at finding quotient and remainder for any given dividend and divisor. In Nikhilya method, actually these are the division. Nikhilya method means actually it is somewhere the dividend is in nearest power to 10. There is near about a power of 10. Like we start with 9. 9 is a single power of 10 means near 10. So first the procedure is learned so that we get an idea, and later on we go for higher dividends, higher amount of dividends. So here, this is my divisor 34, and given 9 is given as a 9 is that this is 34 is the dividend. 34 is the dividend, and 9 is my divisor. With 9, I am dividing. So this is the dividend. Now, how much is short of from 10 is 9 is 1. 1 short. The 1 will be my operative procedure. Here, it is unlike the conventional division. We do not use tables of the divisor. Divisor 9 tables we do not require here. We have to only work with this deficiency that the divisor cuts from the nearest power of 10, the 1. How? Now this 34 I do because it is single digit. This nearest power 10 has 10 to the power 1. So after from right, after 1 digit, we put a slash. This is my becomes my dividing line between quotient and remainder. Quotient and remainder. Also, we can explain like that. I'm sorry. Quotient and remainder. Here, quotient and remainder. So, so had I divided by 10, so 3 would have been my quotient and 4 would have been my remainder. You can interpret that way. Also, simply by procedure, you can also just 1 digit you can do from right. And then 1 multiplied by 3, it becomes 3 here. And then you add up this thing, it becomes 7 my actual remainder, and 3 becomes my quotient. This is the procedure about division by 9. Similarly, I do here 6 into 1, 6 is 7 is my remainder and 6. 123 divided by 9. 123 divided by 9. This 1 comes here, and this 2 plus 1 is 3. 3 again have to write here. So 6 becomes my quotient and 13 becomes remainder. It will go on like that. I'll give a higher with higher dividend with multiple more digits of dividend and to tell you the result in the next slides. Here actually you have to do it operate twice because I'll tell you why. 253 divided by 9. First this 2 came here, 2 plus 2 plus 5 is 7. Again, the 7 came in below this. This makes it 10 as a quotient. Sorry, 10 is the remainder and 27 as a quotient. 27 as a quotient and 10 as a remainder. Now, 10 as a remainder is more than the dividend, so more than the divisor. So, what happens? One more is this one is brought here. So, 1 becomes my final remainder, and this 1 contributes towards quotient that became 28 my quotient, and 1 becomes remainder. I'll tell you more example. 1, 2, 3, 1 divided 1, sorry, 1, 2, 3, 1, 2. This 5-digit number is divided by 9. Again, the 1 is the deficiency, or we work with 1. 1 into 1 is 1. 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 1 is 7. Finally, we add 9 becomes my remainder. 6 plus 1, 7. 3 plus 3, 6. 2 plus 1 is 3. 1, 1. 1, 3, 6, 7 is my quotient. And sorry, 1, 3, 6, 7 my quotient, and 9 is remainder. Again, 9 is the same as this 9. So it becomes contribute 1 more towards quotient, and then 1, 3, 6, 8 become my final quotient, and 0 becomes my remainder. 1, 2, 0, 0, 2, 1. 1 is here. 1 plus 2 is 3. 3 plus 0 is 3. 3 plus 0 is 3. 3 plus 2 is 5. 5 plus 1 is 6. 6 plus 2 is 8. It is because it is less than 9, so it is 8 is my final remainder. And this whole thing, 1 plus 5, or add up all these things, it becomes my quotient. Here,
Guruji, can you please explain this method again? I did not understand it properly.
Okay. I'll repeat like this. I'll repeat. Because actually these examples are given in such a way that you first you understand the thing. These are actually this could have been written line by line. I will tell you that thing in later. Tell the more when the more number of more digit the divisor is there. Here for 9, this is simplified and this is put in one line. That is very peculiar way of writing it. Otherwise, it would have been with multiple lines. I'll tell you how. See, where you got difficulty?
Sir,
See,
like
this,
how does
this,
how does 1, 2, 3, 1 become 136? Sir?
oh, no, I tell you. I start with this. 9 is 1 deficient from the nearest 10 power. 1, so work with 1. 1 into 1 is 1. Okay, 1 into 1 is 1. 1 plus 2, 3. Well, I don't have to say that into 1. This 1 comes below this. 2 plus 1, 3. 3 plus 3 is 6. 6 plus 1 is 7. You understand this?
Yes, Guruji. So you keep adding it to it.
Keep adding.
Yes, Guruji.
Directly 1 you put here. Whatever will given here. Suppose had it been 2, I could have would have written 2 here.
Oh, yes, Guruji. Understood.
1 comes here. 1 plus 2, 3. 3 plus 3, 6. 6 plus 1, 7.
Sir,
so finally again add.
So you multiply the first time and then after that you just add it. Yes.
With 1 we do not consider, simply as if we are copying. Copying and adding. The first one is copying. 1 is 1, and then 2 plus 1 is 3. 3 plus 3 is 6. 6 plus 1 is 7. And this finally we add again 7 plus 9. 6 plus 1, 7. 3 plus 3, 6. 2 plus 1, 3. And 1 comes here. Okay. So 1, 3, 6, 7, 9. But 9 is more same as 9. So again, another will contribute towards that quotient and 0 will be made. Here, 1, 2, 0, 0, 2, 1. This 1 is copied here. 2 plus 1, 3. 3 plus 0 is 3. 3 plus 0 is 3. 3 plus 2 is 5. 5 plus 1 is 6. 6 plus 2 is 8, my remainder. 5 plus 1, 6. 2 plus 3 is 5. 3 plus 0 is 3. 3 plus 0 is 3. 2 plus 1 is 3 and 1 is 1. This becomes my question. 101164. So 1 is copied here. 1 plus 0 is 1. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 6 is 9. 9 plus 4 is 13. The 13 whole thing goes to remainder side. 13 plus 9 is 22, my remainder. And this always added. 4 plus 9 is 3. And this all thing is added. 6 plus 3 plus 4, 0. 2 plus 1 is 1 plus 1. They carry 1, 4. This becomes 2, then 1 and 1. This 22 again, earlier it did in the past case, the 2 and 2 and 2 and this 9. So 2 comes here, copied here, 2 plus 2, 4. 4 becomes my final remainder, and this 2 quotient is contributed towards this one. It becomes 112405. This 2 gets contributed. Okay. Now division by 876. Now 8 is 2 division from the nearest 10. So we have to multiply by 2. Earlier, we just were copying because it multiplying by 1 is same as copying. Now, in every step now, we'll have it multiply by 2. This 2 into 2 is 4. 7 becomes my quotient. Remainder, and 2 becomes my quotient. And again, here, again, 2 into 3 is 6. 7 becomes remainder and 3 becomes quotient. Yeah, with 7, the deficiency from 10, nearest power of 10 is 3. 3 into 1 is 3. This one into multiply 3, so 3 plus 2 is 5. 20 divided by 7. 20 divided by 7. 3 into 2 is 6. So 2 becomes my quotient and 6 remainder. For 6, it is 4. 4 into 1 is 4 and 1 and 5. 234 divided by 8. This 2 into 2 is 4. 4 plus 3 is 7. 7 into 2 is 14. 14 plus 4 is 18. And this is 27. And here actually 18, it becomes more again. I could have done similarly this way. 18, I could have done it this way also. It becomes, as you know, that otherwise, conventionally you can divide also, but like only 2 goes here and 2. 18 if it's divided by 8, it becomes 2 quotient and 2 remainder. So this 2 becomes final remainder and 2 quotient adds here with 27 to get 29. You understand this part? Should I repeat?
Sir, I understood this, sir. Sir, but in the like the overall division part for with the Nicola method, what happens when you're adding the digits and then it crosses 10?
Crosses 10. Crosses the divisor. We do it again. That is.
Meaning
Here,
like, can you explain more on that, Guruji?
This one, no? This
Yes.
14. Yeah. 234 divided by 8. Now this 2 is my division. 2 into 2 is 4. 4 plus 3 is 7. 7 into 2 is 14. Now 14 plus 4 becomes my remainder and 27 becomes my quotient. Now again, suppose I write like this. 1 and 8. Imagine 1 and 8 are written here. 8 is here or 1 is here. So if I again do it like this, 1 into 2 will be coming here. It will become 10. 1 and 10. Okay. You just on the paper you do. Here actually this pen is not working. 1 and 10. 1 and 10 means again 1 and 0 you can do, and then it will finally, you will find that it is 2 and 2. It will be 2 and 2. 2 and 2. This 2 and 2 will contribute here. It will make 27 and 29, and the 2 remainder will remain as it. Here also, another example you get 145 divided by 2. So 2 into 3 is 6. 6 into 6 plus 4 is 10. 10 into 2 is 20. 25 is my remainder and 40 quotient. Again, 25, actually 3, 8 is 24 and then plus 1 to 25. This way also you can see, or you can do in a similar manner 2 and 5. 5 plus 4 is 9. 9 will again contribute 1 and 2 here. So it will be 3 will be my quotient coming from that 25. This 25, 3 will be my quotient and 1 remainder. That 3 quotient contributes after 40, so make it 43 is my quotient and 1 becomes my remainder. Okay. So it is a matter of practice. You just practice it, yourself will understand how it is being done. So with single digit, it is understood. But more and more, with 9, it becomes very easy, very transparent, because things are small here. As you go, so Nikilam method actually works only when the divisor is near about power of 10. So 6 is quite away from 10. So therefore, multiplying by 4 will make it always big, and you have to do multiple steps. So, so therefore, it will fail. Other methods of division has to be borrowed. So these are the special cases where normally we find this always 9 stables. To avoid 9 stables, we use 1. So when it is nearing towards 10's power, our tables, making tables with that device, that becomes difficult. But its deficiency, it becomes smaller as it is approaches towards your power of 10. The device that approaches to our power of 10, its deficiency becomes smaller. So it is easier to handle the deficiency rather than the actual device. So that is the idea. So 6 is quite average. So with 6 it will be difficult, but 9, 8, 7, these are quite manageable. I will come to more examples with multiple digits. Here I come to 2-digit divisor. 89 is 2-digit divisor. With 111, I am dividing by 89. 89, it is near about the second power of 10, that is 100. And 89 is 11 deficient from 100. So we work with 11. Instead of working with 89, we work with 11. 11 into 1 is 11. We add, and 1 becomes my quotient and 22 is remainder. 87. It is 13 deficient from 100. We write 13 here. We work with 13. 13 into 2 is 26. 26 plus 22 is 48. 48 becomes my remainder, and 2 it becomes my quotient. 88. 333 divided by 88. 88 is 12 short of 100. 12 into 3 is 36. 36 plus 3 is 33 is 69. And 3 is my quotient, and 69 is remainder. 1, 2, 3, 4 divided by 880. Normally, if you conventionally, if you do have to do tables of so many multiplication, 8 into, you have to see how much is going and so on and so forth. So, but here you have to do simply by deficiency. Deficiency of 1000 from 1000 nearest power of 10 is 112. Because 112 plus 80. Why it is called Nikilam method? Because you can apply the Nikilam Navatas Charamanga Sutra here. See, this is subtracted from 10, this is subtracted from 9, this is subtracted from 9, 1. When I am telling that it is deficient from nearest power of 10, but we can have a mind of that. You apply the Nikilam method and get it. It is one and the same thing. It is only logical conversion of the thought. So 1 into 112. This 112 into 1. is 112. So 112 comes here totally and becomes 346. 234 plus 112 is 346. 1 becomes remains as a quotient. 789 into it is 211 shorter than the nearest 1000, or you can do 10 minus 9 is 1, 9 minus 8 is 1, and 9 minus 7 is 2. Nikhilam Navatas, Chalamotas. All the are multiplied, all are subtracted from 9, except the last one is subtracted from 10. So 2 into 211 is 422. It becomes, add up, it becomes 767, and 2 becomes my remainder. Otherwise, you imagine this will have to multiply by this thing and subtract, and you ultimately get this same thing. But you have to multiply all these things, 7, 8, 9, you have to multiply by 2. Here only 211 is being multiplied by 2 instead of 789. That is the thing, idea. Now, so far we had division of by 2 or more digit number requiring single processing. This was single processing was sufficient. Now we come to case where can be multiple processing will be required. Not in all, first one is not 1111 divided by 89. So here, I didn't tell you this is why I'm putting this line, because it is near about 100. So 100 had 2 zeros after 1, or 10 to the power 2. So after 2 from right, we put it this one. This is actually near about 1000. So there are 3 zeros, or 10 to the power 3. So 10 to the power 3. So it is after 3 from right, you put this. Or you can say that actually it is, had I divided 1, 2, 3, 4 divided by 1000, 1 would have been my quotient and 234 would have been my remainder. Because it is 1 and 1 too short, it will contribute some more towards remainder. So it is like this. The logic is this. So division by 2 or more digits requiring multiple processing. Here it is 1111 divided by 89. Again we put 1, this 2 is near about 100, 10 to the power 2. So we put 2 digits from right and put a this slash. 11 into 1, 1 is 11. This 11, 1 is put here, another is put towards right of that slash. Slash is the same line we put. And then this 1 plus 1 is 2. 2 into 11 is 22 put here. In this fashion, this very peculiar way of writing initially will look like, but actually it is logical. It can be understood by the algebra. Actually, it is 1 I'm writing, but actually there is the invisible 0 here. So that way 1 plus 2 is 3. It is not 11 plus 1 plus 22. It is 11 plus 10 plus 20. It becomes 43. You do straight away 1 plus 2 is 3. 1 plus 1 plus 2 is 4. And here 1 plus 1 is 2 and 1. So 12 becomes my quotient and 43 becomes my remainder. Here 21456 divided by 789. So 211 becomes my working number, because it is Nikhilam Navatas Charmota Sutra. 10 minus 9 is 1, 9 minus 8 is 1, and 9 minus 7 is 2. Or 1000 minus 789 is 211. Now 2 into 211. 4 we write this way below 1, and 22 we write towards right. But actually, as I told, there is the invisible 0 here. It is not 22, but it is 220. And again, 1 plus 4 is 5. 5 into 211 is 1055. That is, it comes in a total 1025, and matching 6 with 5. So 6 plus 5 is 1. 11. 11 carries 1. 5 plus 2 plus 5 plus that 1 carry is 13. 3 is here. 4 plus 2 plus that carry 1 is 7. 7 here and 1 is 1. So 1731 becomes my remainder, and 21 plus 4 or this 4 plus 1 is 5 and 2 here. 25 becomes my quotient. But 1731 again the multiple processing. So require another processing. 789 divided by 211. This same by again we work in the 1731 divided by 789. This 211 my operating number. 1 into 211 is 211 becomes 942 and 1. Again 942 straightaway because you cannot again apply the procedure because you only same number of digit as this one. So simply you subtract. So one more will come and 942 minus 789 is 153. And another this one came. So this equivalent to one quotient and 942 remainder means actually 2 quotient and 153 as remainder. So these two adds up with this 25 gotten earlier. So 27 becomes my final quotient and 153 as remainder. You please try to understand, then we'll proceed. Which step you are getting difficult or everything is easy? Siddharth?
Guruji, I have to practice this, Guruji. It's not.
Yeah.
I'll see the recording and practice it, Guruji.
Okay. So now, again 789, I divided, I am increasing more digits. So, but you understood that where the slash, first you have to understand what the slash has been put. Did you understand this?
Yes, Guruji. I understood the slash.
Because it is, had I subtracted, had I divided 121,456 divided by 1000, I would have gotten 121 as my quotient and 456 as remainder. But with every 1,000, every 10,000, every 1 lakh, because of this deficiency 211, it will keep contributing towards quotient and remainder both. So I am basically adding up those contributions. Yeah, that is the idea behind this is like this. The conventional method of division gives you what it does is the table of 789 is used because so it is a division is actually repeated subtraction. So we keep subtracting 789. That was the procedure of our conventional division. But this becomes very cumbersome at times. Here, what I'm doing, the division is done in the very beginning. See, division is actually done here. Division by 1000 is done. 121,456. We divide here. Divided, it is final. But by 1000, it becomes the quotient and remainder here. Now, but it is not 1000. I'm dividing by 789. Because of this 211 deficiency, in every case, see here it adds, it contributes. Again, for this is the 1 lakh position, 10 to the power 5. We contributed this much. Again, from the it contributed more, and then the 10,000 position increases. The 10,000 position again it contributes something, and it is here. From the 1,000 position, it contributes and it is here. It is a procedure like that. The procedure is giving that, and finally it matches, and then maybe that will do multiple processing, but that is the idea.
Guruji, I vaguely understood it, but I understood that.
Yes.
I understood that the slash comes because 789's closest base is 1,000, so
Yeah.
3 digits away the slash comes.
Right.
But I understood how you get 211. You multiply it by 1, no, Guruji?
1 into 211, the 211 here, 21 fits here, and 1 actually is thrown towards remainder. But actually, it is mind it is not 1 actually, it is 100. So it
Yes,
will
good.
add up with 4.
Yes, good.
Now,
Good.
again,
How did you get 844 after that? I did
2 plus 2 is
not. 4.
2 plus 2 is 4. 4 into 211 is 844.
So you add the second digits and then.
Second digit, yes. Because already we had one digits below this, no?
Yes, Guruji.
This earlier it 1 into 211 simply 211, but now 2 plus 2 is 4. 4 into 211 is 844, and 1 plus 1 plus 8, this 10. 10 into 211 is 2110. This 0 will match towards 6, and this. But before that, when something is contributed towards left also, means quotient, whatever comes on the right, that will come adjacent to the adjacent to the slash, and it is actually not. This is not 1. This is a 100.
Yes,
This
good.
is not 44, but it's 440. But this is actually 2000 because it is the final one. There is nothing in quotient. It is fully remainder, so it becomes 2110. If we add up all these things, 6 plus 0 is 6. 5 plus 4 plus 1 is 10, 0. And 4 plus 1 plus 4 plus 1, and that 1 in the carry, it will be 11, 1, and 2 plus that carry in the this one previous becomes 3. Here we add up everything, it becomes 150. Okay. 8 plus 1 plus 1, that way 150, and this is. Now again 3106 is more than the divisor. So again it will be the same thing. 3 into 211 becomes 633. Okay. In one go, it goes everything towards remainder. So it adds up, and the 739 will become my remainder, and 3 as the quotient. This 3 gets added towards the previously obtained quotient. So it becomes 153 as quotient and 739 my remainder. Here also I have shown another one. 231456. 211. So 2 into 211, 420. 42 becomes here, and 2, actually 2, it's not 2, but it is 200, below 4. Then again, 4 plus 3 is my the 7. 7 plus 211 is 14. 14 actually could have been written below this one, but actually all the same. It doesn't matter whether you write below or right. Actually, it is below here. So actually, when 3 plus 4 is 7, 7 into 211 is 1477. So 14 came here, actually below 2. So, and then 77. This is actually 770, as I told. This is also 200. Now the tricky question comes. Actually, 14 is below this 1, 2, and 14. 1 and 2. 14 is below 1 and 2. Only not only 4 is below 2, 2 and 1, but it is 14 is below. So 14 plus 2 plus 1 becomes 17. 17 into 200 will become 3587. Still, I should say that is you are doing some calculation, no doubt, but
Sir,
it is still less than the effort of 789. Huh?
Guruji, 17 into 211 you told me, Guruji. But doesn't that become much more than 3587?
17 into 211 is 358.
Oh.
17.
Oh, yes, Guruji. Yes, Guruji, understood.
Okay.
Yes, Guruji.
Now,
so both the 14 should be under the 2, Guruji.
But again, during the calculation of quotient, it doesn't matter whether you write 14 below this or 1 here and 4 here, doesn't matter. But while doing the last step, you have to mind it that don't do 2 plus 1 plus 4, 7. No. 2 plus 1 plus 14, 17. 17 into 211 this. So now it becomes 5013. and this becomes 287. Again, 5013 has to be done processing. So this 5 and 1055, 1068, again 1068 with this 211 you do. So 279. So this 287 plus 5 plus 1 become 293 by quotient and 279. Okay. So this is right. This is finally right. This arrow is arrow, the final. Now, what I comment is there, you just have a academic this thing. As it becomes more away from the nearest tens power, it actually this method actually requires either some modification or either conventional division also find, or there is a state division method. It will be taught in the second level of Vedic mathematics course that has to be applied, but here not. So to prove that, I have put this one. It is quite away from the nearest tens power. It is actually 346. Therefore, everything will be bigger and bigger and bigger. So you require earlier we did with 3 steps. These are 2 steps. These were 3 steps. One is this, the second one is this, third one is this. But here you see there will be 4 steps required. One is this, this procedure and gives to 492 and 19799. Again do 19799. All this it becomes 22 and 5411. 5411 again you do to become 1730 and 5 and these things, and again you do 2 and this one and 833, and again you have to subtract. So it becomes 3 and 179. In fact, 5 steps. So adding up all these things, 492 plus this 22 plus this 5 plus this 2 plus this 1 coming out of subtracting 8 because it's same number of digits. Only subtraction will be applying here. 833 minus 644, this 1 and 179. So this 1, because I put it together, 3. So 492 plus 22 plus 5 plus 2 plus 1 is 522. So it actually becomes very, this procedure is no more good to apply. So there will be other methods. Again, the sub-base technique comes here. In those kind of cases, there will be sub-bases also. So I consider 1011 divided by 23. Now you find that 23 into 4 is 92. And it becomes, you have to find out which multiplication or division of something goes near to a power of 10. So 23 into 4, I find it is near about power of 10, 92. So first I do 1011, I simply divide by 92. So 92 is 8 short. This 1 into, this is, but we write the, preserving the number of digits, it is 08 short actually. So with 08, 0 and 8 comes like this. 1 into 08 is 08, and 0 plus 0 is 0, and this. So no more writing here. And 8 plus this thing, it becomes 91. 8 actually not 80, but 8, but actually 80. So 91, 10 and 91. Now, with division by 91 would have been my 10 quotient and 91 remainder. But 91 actually, but we are not dividing by 92, but actually wanted to divide by 23. So within 91, there are 3 numbers of 23 is fitted, and 22 becomes my remainder. So these 3 contribute, and another thing, by multiplying something by 92, if the 10 becomes my remainder, had I subtracted, had I divided by 23, obviously 40 would have been my quotient, not remainder, quotient. So if something we divided by 92, 10 was my quotient. But if I divide, there is 1/4 of that thing, So obviously 4 times more you will fit. So 40 becomes my multiplier here. 40 becomes my, because here also by multiplying we got it. So here to multiply. That is how you remember. So this 40 becomes my quotient, and 91 remainder, but actually 91 remainder becomes like this. So 43 becomes my final quotient and 22 remainder. So you just try to understand. Got it?
Yes, Guruji.
Basically, 92 into 10, 92 into 10 is same as 23 into 40, isn't it? That is ideal. And 91 remainder was good for 92, but it is 3 more will fit for 23. So 3 is fitted, and 22 is become my final remainder, and that 3 contributes here. Okay. So that is the idea. Now, so up till now, everything clear? Is that? If we require, we discuss it later also.
Yes, Guruji.
One second, please. Okay. Now, here another method is it was Nikhilem method. Here is Puravarta method. But actually, logically, actually, it is just almost same as this Nikhilem method, except it was deficiency. Deficiency from the nearest power of 10. Deficiency from the nearest power of 10. But now it will be excess from the excess above the nearest power of 10. Paravarta division means transpose and apply. In Paravarta method, result of excess of the divisor from the nearest power of 10 is 1. Divide 1, 2, 3, 4 by 1, 1. So again, 1, 1, 2 is the nearest power of 10 is 100. So we put again that same thing we do, that 100 has 2 zeros. So with 2 digits we put a slash. The 12. Had I divided by 100, to 12 would have been my quotient and 34 would have been my remainder. So that way I put also the logic is this. But 1, 1, 2, I write -1, -2. We could have written Vinpulam also, above also we could have written -1, -2, because it is 12. But it is deficiency. Deficiency is -12 deficiency, means actually 12 excess. Now work with exactly the same way, but with negative. 1 into this -1, -2 becomes -1, -2. 2 minus 1 is 1. And again 1 into -1, -2, -1, -2. And 4 minus 2 is 2. 3 minus 2 minus 1 is 0. And 12 minus 1 is 11. So 11 is my quotient and 2 is the remainder. First, you understand this? Here it will be, instead of earlier, we always will increasing, but here we are decreasing also. Earlier it would have 2 plus 1, 3, and become more and more. But here it is becoming less. So you can 1 minus, here also is -1, -3, here also -1, -3. Here it is like this. So 1, 1, 2, 3 divided by, 1, 3, 4, 5, 6 divided by 1, 1, 2, 3. So it is actually -1, -2, -3. You have to write this. To cut down this 1, it is actually 123 excess of 1000 nearest power of 10. So again we put with 3 digits here. 1000 has 3 zeros. So -1, -2, -3. So this into 1 becomes -1, -2, -3. And then 3 minus 1 is 2. 2 into -1, -2, -2 is 3 is minus 2 minus 4 minus 6. 6 minus 6 is 0. 5 minus 3 minus 4 is minus, and 4 minus 2 minus 2 is 0. So initially 12 becomes my quotient and minus 20, 12 becomes my quotient and minus 20 becomes a remainder. That means again this 20 has to be subtracted from this. Actually, I have done excess. 12 cannot be my quotient in that case. So 11 becomes my quotient and this 20 had gone excess. So 20 must be subtracted from, as I'm telling more, contributing towards quotient, it was more. Actually, quotient is not that much. 11 was my quotient and 1103 was my remainder. It is like this, you can say 12 into 1123 minus 20 is same as 11 into 1123 plus 1103. It is like this. With practice, we will understood that what is negative in the quotient means, negative in the remainder means what? Negative in the remainder means is that you have to reduce the quotient by 1 and you subtract that much from the divisor. Okay, clear? You understood how 1103 came?
Yes, Guruji.
I give more example. 3, 4, 5, 6 divided by 1, 2, 3. 1, 2, 3 again minus 2, minus 3. 2 into minus 2 minus 3 becomes minus 4, minus 6. 3 minus 4 is minus 1. Minus 1 into minus 2 minus 3 becomes 2, 3, 23. But 3 goes towards right. Actually, it is 30. And then, why is this 0, 0? 4 minus 6 plus 2 is 0. 0 into minus 2 minus 3 is 0 and 0. So 6 plus 0 is 0. 5 plus 3 is 80. Number 8. And 4 minus 6 is 0. 3 minus 4 is minus 1 and 2 is 12. This, as you know, vinculum notation, 2 and minus 1 becomes 1, 9, isn't it? Earlier we have learned. This is same as minus 1 in the digit means 200 minus 10 plus 0 is 190. So actually minus 1 is this means it's 190 here. 2 and minus 1, 190 and 86 becomes my remainder. 4009 by 882. 882. Because actually it is same as Nikilam method, but here you do slightly apply in a different format. Same thing as Nikilam or Paramartha method becomes intermingled here. Here you write in this format. Simply 118 was there. This is the deficient from, this is deficient again. Deficient from the nearest 1000, not excess. But 118 you express as 1, 2 and vinculum 2. Vinculum are same as negative. 1, 2 minus 2. Here I'm doing Nikilam here actually. 4 into 1, 2 minus 2 is 4 plus 8 minus 8. 9 minus 8 is 1. 0 plus 8 is 8 and 4. So 4 here, 4 and 480. Two 699 divided by 220. So far we do it excepting this one. This was a special case here. But earlier we did 100 something. Always we did 100, 1000. First digit was 1, but now suppose first digit is 2. 2699 divided by 224. So 224 divided by 2 is 112. We work with 112 and this minus 1 minus 2 is my excess. First I try to divide by 112. We'll do next processing after that. So 112 minus 1 minus 2 into 2 is minus 2 minus 4. 6 minus 2 is 4, and 4 into minus 2 minus 1 minus 3 is minus 4 minus 8. 9 minus 8 is 1. 9 minus 4 minus 4 is 1. 6 minus 2 is 4. 2 minus 2 is 2. And then, but we divided this thing. So we divided the 2699 by 112. Instead of that, had I divided by 224, my quotient would have been half. So we quotient we make half. So becomes 12 becomes my quotient, and 11, it is not affected. 11 when a remainder is not affected by this division. In case of multiplication, it affected because 23 was more smaller than 92, but here 224 is more than 102. So anything dividing by 112 leaves some quotient, leaves some remainder will be intact here. So remainder it becomes intact, but quotient gets reduced by half, 12 and 11. But this challenge comes when it is again half. This half actually gives lot of problem. Should I discuss today or let me see what is there? Okay, we'll discuss. How much time is there? Maybe that with this one I'll end it today. Tomorrow we'll keep. We will have side discussion, theoretical discussion, and then we'll end. 1699 divided by 223. Earlier I divided by 224. It is an even number, so when it is half, there is a integer. But problem comes when it is half, it became 111 half. We keep it along with 1, so it is 1.5. So it is actually minus 1 minus 1.5 more than 100. So it is minus 11.5 more than 100. So this minus 11.5, 1 into that minus 11, 1 minus 1 minus 1.5. 6 minus 1 is 5. 5 into minus 1 minus 1.5 because minus 5 minus 7.5. 9 minus 7.5 is 1.5. 9 minus 5 minus 1.5 is 2.5. 6 minus 1 is 5 and 1 is 1. This when we divided by 2 again, earlier we also did divided by 2, 24, it becomes 12. Here 15 it becomes 7.5. And then this becomes 9 minus 7.5 is 1.5. 9 minus 1.5 and 5 is 2.5. So 7.5 becomes my quotient and 2.5, 1.5 becomes my remainder. But how to interpret this? It is like this. Quotient is 7 actually. But this half in quotient actually becomes half of this. So it will remainder will contribute 111.5. But 223 divided by 2. 223 into this half is this one. And 2.5 in the tens place actually is 25. 20 plus this half into it becomes 5 to 25. And this plus this 1.5. If you add up all these things, become 138. So 7 becomes my quotient, and 132 means my remainder. Remainder remains constant while dividing quotient by 2. And presence of half in quotient will contribute half of divisor, half of the divisor, mind it. Half in remainder will contribute towards according to the position. It will be half here in the unit. It will be 5 in case of tens. If it is a half is found in the 100 position, that will contribute 50. So that way we have to understand the meaning of half in the different digits. But on the quotient side, it becomes the half of the divisor. So it is totally, if we add, it is 138. So quotient will contribute half. It is clear, Siddharth?
Yes, Guruji.
You practice it, you will find that you enjoy it and you practice it, and it is a special case.
Yes, Guruji.
Huh?
Yes, Guruji. I'll practice it at home.
Tens digit is tens position. So 2.5 into 10 is 25. That's why 25. And this is anyway 1.5. Huh? And this is half of that. This one. Okay. Now, now I'll go to slightly theory so that it becomes the background of tomorrow's class. I'll just discuss this one and then we can leave. So far, we have seen division of a dividend by a divisor to yield a quotient and remainder. Relation between these three are that dividend is equal to divided into quotient plus remainder. Make it easy where we are actually dividing, so we are getting quotient and remainder. But actually, relation between these things are like this. Or when you are dividing this a number by dividing, we are getting a quotient. But you can express this way also: E by D is equal to Q plus R by D, where R is less than D. Now, depending upon the requirements, division may be left at finding Q and R only. We so far we did like that, or we may have to express it in the form as shown above up to R by D as a fraction. Like we express like R by D in decimal format. For example, 15 divided by 4, we write. Either you can write quotient is equal to 3 and remainder is equal to 3, or 15 by 4 is equal to 3 full and 3 by 2. Is it there? Or we can write, again we do a decimal point, 30 divided by 4 we do, and then becomes 7, and again 2 is given 2, 20 divided by 4 is 5. So that way we did when handling the decimal point, as we know decimal division to 3.75. For an expression E by D, where E greater than D, it can always be expressed as a whole part like this here, plus a fraction of the form N by D, where instead of remainder, in general it's called a numerator, where the numerator N is less than the denominator D. So then you, instead of remainder and divisor, we call them numerator and denominator. So maybe we can keep for next class. Which one? Or can I continue? Slightly more? Up to
We will
8?
set for today.
Okay, enough for today. Yes. We already started before. Fine. You can go through and so that tomorrow it will help.
Okay, Guruji. Recite Prarthana.
Practice the division, whatever we taught. Any question from the division part? This one. Eh?
No, Guruji, I just no specific.
Practice, go through them again.
Yes,
See
Guruji.
if any problem comes, you tell me.
Yes, Guruji.
Thank you. Namaskar.
I'll recite the Prarthana. सर्वे भवन्तु सुखिनः सर्वे सन्तु निरामयाः सर्वे भद्राणि पश्यन्तु मा कश्चित् दुःखभाग् भवेत् ॐ शान्ति शान्ति शान्तिः हरिः ओम् श्रीगुरुभ्यो नमः हरिः ओम्.
What Sharma was that? I didn't interact with him.
Guruji?
Or Sharma was there. Oh, sorry. Anyway.
I don't know, Guruji. Who is that Sharma? Maybe a class student, probably.
Yeah.
Namaste. Hari Om Sharma. Sharma ji.
Sir, madam.
Yeah, you can show your video.
Sir?
You can switch on video so that you can see you.
Okay, sir.
You didn't interact. You could have asked some questions.
Sir, I listened the class.
You got it? Got the ideas?
I don't know where the
He could have interacted.
mathematics.
Like Siddharth ji included when he asked the questions. See, Siddharth ji has having exam, but still he he was interested in listening to this Vedic lectures. So
Okay.
okay, namaskar. So national anthem is there.
Sir?
Like that. You can stand up for that. जनगण अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल वंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष माहे गाहे तव जय गाता जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे जय हिंद. We will close the session for today. We'll close the recording for now.